So I guess if you can give me a thumbs up if you see my browser, is it sharing properly? All right, well, thankfully Google Meets didn't completely bomb out on us. Okay, good. All right, so what I'm looking at here is the Arista collection, and then I also have the Cisco collection. So I have them both up so we can use that as a comparison. So with that being said, with the Arista EOS, hey, my video died too, but it looks like my audio is still working, so that's good. With the EOS modules, the ones that we want to look at for interfaces are actually 3 different ones, but primarily we'll be looking at the interfaces and the layer 2 interfaces. And then the layer 3 interfaces, because I do have some SVI configurations and a layer 3 interface port on the switch itself. So we'll interact with this module a bit. But most of the work is from the interfaces, which is more around physical configurations for that device. And then the layer 2 interface module is around, access VLAN stuff, private VLANs, trunks, those types of configurations. But one thing that we have to understand from configuring devices is there's some limitations in terms of gaps of configurations and parity to configurations that don't exist in all these resource modules. So the reason why I kind of started here with the resource module, just to point this out, is I always gravitate towards the resource modules because they are more declarative and they offer you built-in diffs and different state options of what you want to do when you apply the configuration, like whether you want to merge it or replace it or override it or delete it. It's very powerful in the sense that I can take like command line and translate it into structured data. So you can render configs, you can parse configs. So parsing would be taking the command line and turning that into structured data, and rendering would be the structured data and then converting that to command line. So it does a lot of things for us. So it's definitely valuable, and I lean towards those. But again, there's times where there may be a configuration that's not covered, directly in a resource module. So for those instances, then normally, like for a workaround, I have to decide like how best to do that. So I'll kind of table that for a minute and we'll come back to that, but just know that there are some gaps. And in my example, I have to account for some of those gaps in coverage for the configurations out of the resource modules. So one module that's used a lot, especially when folks are just getting started with using Ansible, a lot of times for network automation, they'll use the configuration module. So each one of the vendors, in this case, this is the Arista EOS, provides a config, right? So this one's EOS_config, and this is just the namespace, right? So to have access to a module, they're packaged into a collection, and the namespace for a collection starts with the vendor, and then the name of the collection, so EOS for Arista, and they only have one type of OS for this, so we don't have to deal with like nuances here. But like with Cisco, there's the iOS, the iOS XR, the Nexus OS, right? And then the last part of the dotted decimal notation in this namespace is the name of the module. So the EOS_config, or you could just put .config. This gives you capabilities to config from a command line perspective. Anything that you can config from the command line, right? So anything that you want to automate from a command line, if there's a command line to do it on the device, then you can accomplish it here. But the challenge is the performance, right? So, and also like the scale, like how many of these devices do you need to touch and how many ports are we talking about? So in some cases, it really doesn't matter as much in smaller environments or switches like with 24 ports or even like 48 ports versus when you start talking about a core switch or distribution that has, hundreds of ports, then we start to see that performance penalty depending on how we're, configuring these playbooks. So before we get into the performance, just like how do you use like this module as an example? So there's 2 different ways that I can configure devices using the config modules. One of those is using the lines parameter. So what all this means is that it's no different than pasting like line by line into the device. I just have to do it at the proper level depending on how nested the configuration is. So lines goes in by default at the config T level, right? So something like an NTP server or an SNMP community string is at that level. But when we start talking about interfaces, then underneath interfaces, there's nested configuration. So to get around that, there's a notion of parents. So the parents would be like the interface name. And then underneath the parent, you would have lines. So under the interface, gigabit, Ethernet, whatever, I could have an IP address, a net mask. In this case, we're talking about, layer 2 things. So we could have, switch port, access VLAN or switch port trunk. Those types of configurations that go under the interface would need a parent so that it would, navigate to the proper point to that location where it is in the actual command line running config. So we need to know a little bit more about the command line because we have to put this together with proper syntax, right? Because if you don't have syntax from a line perspective, it'll fail. But if the line is introduced at the wrong hierarchy, right, it'll be a bad config too. Right? So it just depends on that specific configuration. But if we know what we're doing with the config, we can use parents, we can use lines, we can use another parameter called before if we need to remove a command. So if we need to do a no to negate something, so something like like an access list type of thing, where we do that before, and then we go to the parent. We can do all of that. So it gives us a way of like orchestrating how we would typically interact with the device directly, but through the playbook. Because we're not there prompted to be able to do no's and then put the command and change things around. We need to run it from the order that it needs to be sent, from this playbook. And all of that works. So there's nothing wrong with that. There's nothing that you can't configure that way. But just think of it at scale, doing those types of things. You're iterating through these lines as an example, and that takes time. So when you start to multiply that times how many devices, how, at or an order of magnitude greater depending on how many ports, right? So that starts to add up. So another option that you have from the config module is you can run here at source, you can run Jinja 2 templates. So Jinja 2 templates are very similar in the sense that they are syntax specific to what you're building, what you're configuring. But when you read in the Jinja 2 template, it's much faster in the sense that you're not creating like loops or needing to create loops in your playbook to iterate through these interfaces. You can create like a config file that you iterate through in your Jinja 2 template, and it's able to do that much quicker and send that config to the device. So there's a source parameter, and it pushes that configuration into the device, into the running config. So not to be confused with like the template module where there's a source and a destination, because that's mainly for creating like a file or like something like a web page where you're actually, the output is going to a file. This output is the serialized data in command line form that's being pushed into the device. So you can push a config in its entirety using Jinja 2 templates, or you could build like a file if you want to create like a config file and save it like to a repo or a server, and then use that to push the entire config. What I'm talking about in my examples today is using Jinja 2 to round out some of the configs that are not available in the resource modules for bits and pieces of configs that are not in scope there yet, but I'm able to add those configs very quickly to the device. So you'll see that. So the first example we'll go through is using the lines parameter and see like, yeah, that one works, but definitely you can see it's going to take a long time if I had a larger switch. And then we'll move towards using the resource modules and then round that out with Jinja 2 templates. And then the third option that's very quick, because you don't even have to send the serialized data to the device, is the Catalyst switch. So the Catalyst switch with iOS XE offers templates that you can create on box. So you can just call those templates from your resource module. So you can create like it's not a Jinja 2 template, it's an iOS template. but you can have like an interface version of an iOS template that you can call, and it'll configure your interface and assign it to whatever ports you want to, along with the resource module ports. So that happens very quickly, and it takes the load, off of the front end side of the automation, and it applies it to where it already exists on the device. So these templates are built in for things like IP phones, cameras, basic use cases for switches. There's templates that if you did a show template, interface all, you'll see all of the built-in templates that exist. But what I'm using today that's a little bit more interesting than that is the ability to use Ansible to create a custom template on the device, and then I apply that template to how many ports that I want to apply the template to. And then that helps greatly in terms of performance. But unfortunately, that notion of the interface templates for iOS doesn't translate over to Nexus, and Arista doesn't have that either. So a lot of times you will have to use the Jinja 2, which still offers good performance, but it would be nice, if everybody had like an on-box templating. But since it's already there on Catalyst, if you have Catalyst switches, then you should take advantage of it because it's very easy to use, and you'll see that here in a second. So the other thing here is, if I go into the Cisco one, just to show you here, there is no parameter called template. So Arista hasn't gotten on board with that capability on their platforms. But when we go into the Cisco config module, or interface module, I'm sorry, the interface module. Let me just do a Control F. Find it that way. Yeah, it's this one right here. So this is the iOS template name. That's all it is a string parameter. So you can only apply one of these templates to an interface. So that's why it's good that you can create a custom one, because then you can include whatever commands you want, for that custom template. The other out of the box ones are mainly, around like specific use cases, like I mentioned, like cameras and phones and things like that. So I created one for port security and for augmenting my configuration for private VLANs of some things that didn't work in the module, or didn't exist in the resource module, that I needed to round out in my config. So unless anyone has, let me jump back over to this screen. Okay, just making sure there wasn't any questions in the chat room. If everyone's good from this point, I'll go ahead and start showing some of this, unless somebody has a glaring question that you'd like to ask right now, mainly around like those modules. All right, I'll take that as let's move forward.